So in the previous video, we saw how re-renders happen in React and how they can silently degrade your app's performance. In this video, we'll fix that. We'll do that by organizing our components and states smartly so that React re-renders them only when it's necessary. So let's start with the most common problem, which is placing the state too high in the component tree. So this is a very common pattern where you have a top level container component that handles logic, data fetching and state. Then you have a presentational component that focuses only on rendering the content, rendering UI. But just because it's a common pattern doesn't mean it's right. So take a look at this example. So you essentially have three components: a selector component, a display component, and an unrelated component. Anytime I update the selector component, this display component will update because the state has changed, the selected state has changed. And since display also has a prop, which is essentially the same state value, it will also re-render. But the problem here is this unrelated component, which has nothing to do with that state, this component will also re-render. The most obvious fix here would be to split the components and move the state down. This is also called co-locating the state. So isolating state closer to where it's needed makes more sense. And that's exactly what we'll do here. So what we have now done is move the state to the selector component, which essentially holds the button and the display component that are actually using the state. So since we have isolated the state to the components that need it, now the unrelated component won't unnecessarily re-render. So we have just positioned the state closer to where it's needed so that it's not causing any unnecessary re-renders. So essentially, if a component re-renders due to state or props it doesn't use, you might need to split it out. Another silent killer that you would see in a lot of apps is prop drilling. You basically have a deeply nested tree and state is being passed from top to bottom, component by component. This unnecessarily creates tight coupling, and a lot of times the components in the middle don't even need the prop. They just have it because it has to go down through them. They are essentially in the middle of the hierarchy. All of this seems very wasteful, and there are a lot of ways now to get around it. You can use React's context API to solve this problem. Wrap your component in a context provider and pass the data that it needs to be shared in the component tree. Then you can use it anywhere in the tree without having to pass unnecessary props. But context has a cost attached to it. So when you wrap your provider around a component tree, if the value in the context changes, the entire tree will re-render. So all the components in the tree hierarchy will be re-rendered even if some of them are not even using the data from the context. Instead of React context, you can use Zustand or Redux. These state management libraries use a subscription-based model. So consider Zustand for now. There's this store that you'll normally create, which takes care of creating and updating the state. You expose the state and the methods used for updating the state from this store, and any component that wants to use these exposed objects and methods can subscribe to them. Only those components now will be affected, and the ones that do not use the store won't re-render. Speaking of state management tools, while you can technically use anything anywhere, it's better to use the right tools for the task. If it's local component level UI, using useState or useReducer makes the most amount of sense. If it's global but not frequently updating state, like say for instance theme configuration or authentication configuration, React context would do. If it's more granular state that has to be passed to multiple components across the tree and also updates frequently, Zustand, Redux, Jotai, any one of these state management libraries make sense. Finally, if it's server state caching, like caching API responses to avoid multiple redundant requests, React query makes the most amount of sense. There are other libraries like SWR, but as of now, TanStack or React Query has been established as the industry standard. 1 out of 5 React projects do have React Query in them. So clearly it's one of the staples in the React ecosystem. So that makes more sense. React Query is a huge separate topic altogether, and I have a full tutorial series on it. You should check that out. I've linked it in the description. So quickly summarizing all of this, co-locate your state, isolate it to components that actually need it, only lift the state when it's absolutely necessary. Split UI and logic into separate components so that you don't get unnecessary re-renders. Avoid context for dynamic high frequency state, because context is going to update the entire component tree at least the component tree that is wrapped by the provider. So if there are components in the component tree that do not really use any part of the context, anytime the context value changes, the entire tree is going to update. So this is an unnecessary render, and you can avoid it by avoiding context for things that update frequently. Pick the right state tool for the scope. You have useState, use reducer to handle local state. You can use context for things that don't update frequently. You can use dedicated state management libraries to actually maintain the state that updates frequently. And finally, something that I didn't cover in this video, you can use memoization at the very end. Never actually start with memoizing things. Only when you think there are things that can be computed once and then reused across renders, use memoization. We are actually going to cover this in the next video. There are a lot of caveats around memoization hooks, use memo, use callback, and even the higher order function react.memo. People don't exactly know what they do, and I'll try to clear up that gap in the next video. We'll focus strictly on memoization and its intricacies, so do subscribe for that. And that's pretty much it for this video. I'll see you in the next one.